So 3.2 is looking at samplings. We're going to look at some samples, methods of sampling. We're also going to look at some of the downside of other methods of sampling. So the reason you sample is because the population, the entire group of individuals, usually is too big. Okay? You're not going to be able to test, question an entire population. It takes too much time, takes too much money. Just really, sometimes it's just not realistic to think you're going to be able to ask everyone. So what we do, we take a sample, part of the population. And it kind of has to do with a pot of soup. Okay? If you're cooking a pot of soup, you don't need to taste a huge bowl of it to know if it's good or bad. You can take a small spoonful. As long as everything's mixed up, it's a nice random mix of everything that's in that soup. You take one spoonful, you can tell what's going on with that soup. Is it good or is it bad? Okay? So we have population, we have samples. In statistics, we use a lot of symbols, and just I'm going to introduce a couple of them real quick. Okay? We have sample statistics, we have population parameters. Okay? When we're talking about the statistics, we have mean, we have the variable bar, which in this case it's y bar, mu is the parameter. Okay, I'm going to let you read through those. You might want to pause it and jot these down real quick. The key ones you should look for: mean, standard deviation, and proportion. Okay? Yes, I might have a copy down correlation, the regression coefficient. I'm not horribly concerned about them for this course. Mean, standard deviation, and proportion are the three that you should focus on for what we're going to be doing in the problem stack. Okay, so population parameter of interest. Okay? This is really the question or the answer of what we're trying to look for when we're looking at a study. Okay? A survey was mailed to all adults and got a response rate of 73%. Of the responses, 25% said they stay at home during vacation because getting to the vacation location is too much of a pain. Okay? So we have two percentages in there. One is the rate and one is the percentage of the sample that we got. Of all those people that responded, we found 25% say they stay at home because it's too hard to get to their vacation. Okay? The population parameter of interest, and the key word in this, I feel one is percent. The percent of the population that stay at home during their vacation because getting to the vacation location is a pain. Okay? This saying percentage here, this is telling me that it's a categorical data and we're looking at a percent of the population here. Okay? This last part is just really describing the question. Okay? We asked how many people stay at home because they don't like getting to their location. Okay? So when you're asked for parameter of interest, think about what type of data it is. This was categorical. It was either yes, I stay at home, no, I don't. So it was a percent. If it was quantitative data, numerical data, you'd say the average, and you'd be looking at that. It might be the average of the population spends on going on vacation. So you're going to have to think about what type of data I have. Okay? Sample surveys. Okay? This is a good way of collecting data. This is really just a questionnaire. Okay? We talked a little bit about questions before, so now we're going to be looking a little bit more at it. Okay? Poll used to estimate what a population is thinking. Again, it's a survey, questionnaire. Okay? Ask the question, gather information from the population. Okay? Three main ideas. One, examine a part of the whole. This is the idea of sampling. Okay? We're only going to take part of the population, and from that part of the population, we're going to generalize it to the entire population. So it's very important that part that you take represents the entire population. That's where the sampling method comes in. Okay? A census is if you're going to attempt to take the whole population. Again, we try and do that, and that is the best way to do it, but it's unrealistic. Okay? It's not going to happen in many situations. Okay? Randomized. This is where if you have a random sample, there's a good chance it's going to represent the population very well. So you're trying to get a random sample. Okay? And sample size. Okay? Yes, you can take a random sample, but if you have a population of, let's say, 13,000, if you take a random sample of 5 people, most likely that's not going to represent the population. Okay? So you do have to make sure that it is a large enough sample that you will be able to touch every proportion, that you're going to be able to get a good representation of the population. These do not have to be determined. Randomization sample, that's not have to be determined in your method. It also, your money and your resources are not have to factor into that as well. If a sample reflects the corresponding population, then we call that sample representative. Okay? If your sample represents the population, okay, it's a good sample. Then you can generalize that sample, the results of that sample, to the entire population. Okay? Sampling frame. List of individuals that the sample is drawn from. So these are the people that are able to take part of your sample. Okay? So it might be, okay, my sample is high school seniors. Okay? My sampling frame, if I go to school on a Monday, my sampling frame are the seniors that are in school on Monday. They're the only ones who are able to take part of the survey, of the study. So that is what's considered my sampling frame. Okay? There will be some people that are left out of that, and that's going to be a problem we're going to have to deal with. Okay? A simple random sample. This is what you want. This is the best type of sample that you're going to be able to get. Okay? And the important thing is every individual has an equal chance to be a part of the sample. And that's really the hard part. Okay? Here's our sampling frame. Okay? How can every person have an equal chance of being picked? Okay? I mean, it might be technical that not everyone has an equal chance, and it might be conscious. The person who is doing the survey, they just might subconsciously be picking one group more than another group, and it's those are the things that we're going to have to control. Okay, so some other methods that we do to get a good sample. Okay, we have a cluster sampling. Okay, cluster sampling. Subdivide the population and select whole subdivisions to sample. Okay, your subgroups should be similar. Okay, so you're not just randomly saying, okay, here's 20 people, here's 20 people, here's 20 people. There's going to be a reason those groups are going to be put together. Okay? So the example I have here, the population are kids in a high school. The kids are divided into homerooms, and homerooms are picked, and the entire homeroom is surveyed. Okay? So what we're doing here is, okay, here's all of our kids, and usually homerooms, they're usually put together by grades. Okay, so it's not just, okay, here's a random group of students. It's here's a homeroom. These are 20 seniors that were put together. Here are 20 juniors that are put together. So those homerooms are similar to each other, and you're not randomly pick homerooms. What this does, it saves time on traveling. Okay, instead of having, okay, let's randomly pick 100 people. Now I have to travel to all these different homerooms to get those people. Okay, I might say, okay, I'm going to randomly pick 4 homerooms, and those 4 homerooms may add up to the 100 people, but I'm going just to 4 locations. So cluster sampling is going to save time in that aspect, that you might not have to travel as much. Okay, and since every homeroom, I mean, let's say our homeroom is high school students. Okay, we're selecting that homeroom at random. That is going to represent our population. Okay, so that homeroom could be a good sample, a good part of it. Now, cluster sample is very similar to stratified sampling. Okay, and it's similar because we have our subdivisions again. Subdivide the population and take a sample from every subdivision. Okay, so this time, every single subdivision we have is going to be picked a little bit from. Okay, and that's to ensure that we canvass the whole population. Okay. Here we have the population of kids in a high school. The kids are divided into grades, and 15% of the kids are picked from each grade. Okay? So let's compare these two groups here. If we do cluster sampling and we randomly picked 4 homerooms, is there a chance that 2 are seniors, a junior, and a sophomore homeroom are 4 homerooms? Yes. Now the problem with that is freshmen were left out. Okay? So does that really represent our population? Not so much. If we do stratified sampling, okay, we're going to take 15% of seniors, juniors, sophomores, and freshmen. Every single one of those grade levels are going to be represented in our sample. So what you need to think about is the situation and how you're doing your subdivision. If a subdivision is left out, will that make your sample not representative of the population? Okay? Okay, and the groups that, when you're subdivisions, they are considered strata. So if they ask you, what is your strata for the sampling method, they're asking you, how did you subdivide? So we are subdividing by grade level, subdivide by homeroom. Okay? So that's what stratas are. Okay? So cluster versus stratified. When to use which type of sampling. And this is pretty important. This is what you're going to have to decide. So let's think about Pennsylvania. Okay? Here's all the counties in Pennsylvania. Let's say we're using that as our subdivision. Okay? Now, if you're going to do a cluster sample of Pennsylvania, okay? If you randomly pick, say, 5 counties, okay? Let's think if you randomly pick 5 counties, we picked 1, 2, 3, 4, and let's say 5. Okay? And that all those counties, everyone in those counties were able to be sampled. Okay? That would be considered a cluster sample if I randomly selected those 5 counties. Okay? But you have to think about Pennsylvania though. Okay? If we're asking about something about how you feel about taxes or something, and really what you need to think about is, do these 5 counties represent the entire state accurately? Okay? This is definitely my opinion, but I'm gonna say no. Okay? If I'm thinking about Pennsylvania, we have 2 very urban areas. Okay? We have Pittsburgh and we have Philadelphia. Okay? Those areas, the surrounding counties, are much more suburban, they're more urban, compared to the central Pennsylvania, okay, where it's much more rural in that area, a lot more farmland. Is the demographic the same? Okay, and I'm gonna have to say no. These 5 counties that I picked here might not represent Pennsylvania because of the large population in the southeast for Pennsylvania, where Philadelphia is, and where Pittsburgh is out west. They might not represent just as good as a stratified, because if we're looking at stratified sampling, what we're going to do here is we're going to take a small sample of every single county. So that means every county might not be a huge group of people, and you get the point. I'm not going to put a dot in every single one, but that means that the urban areas, the rural areas, everyone's going to be touched on. Okay, so since these sample, the population is our entire Pennsylvania, it is important to get everything touched on. Okay, it's important to get the entire state marked off here. So again, it's going to depend on what your study is. What is your study asking about? If you're going to be able to use a cluster sample, or if you're going to be able to use a stratified sample. It's going to depend on how you do your subdivision and the question you're going to ask. Okay. So moving on from those 2 samples. Okay, systematic sampling, just a couple more methods here. You're picking every nth individual. Make sure you have a random order first, usually alphabetical words if you're looking at people. Usually alphabetical order doesn't really change your opinion if your last name starts with an A or an M or a Z. Okay, but you're using every nth individual. A lot of times the manufacturing line, as it goes through, you're not selecting just the first 5. Okay, you're not select maybe every 10th. So it gets warmed up a little bit. You see the ones in the beginning, the ones in the middle, and the ones at the end. Okay, start at a random place, not the beginning. So you're not want to start, okay, if the group is individuals in alphabetical order, I'm not just going to start at A because we might get enough people before we actually get to the end. So it's say, okay, randomly we're going to start on H's, and that's where then you would start counting off by. Okay, multi-stage sample is just putting multiple methods together. Okay, so it's just having different stages of randomness, different stages of subdivision. Okay, break down the states of Pennsylvania by county, select 10 random counties, stratify by school district, then take a simple random sample of 10% of the high school students. So first we are subdividing by county, a random sample of counties, and then grouping them again, stratified by school district. So there's multiple stages of randomness and subdivision there. Okay? And sampling variability, this is just going to be the difference from sample to sample. What's the difference between those? And again, we're not looking at their answers this time. We're not seeing, okay, this group said this group said this. When it talks about sampling variability, we want to make sure that every sample represents the population. You don't want one sample that is all seniors and another sample that is all juniors if you're going to be comparing the two. You want to have a mix of everything, so everything needs to be representative of the population, okay? And it should be proportional, the way we're thinking about it, okay? So those were some sampling methods. The second part of this lesson is I'll look at some of the downside of sampling, what can go wrong if it's not done correctly.